Time is one of the biggest obstacles to creating games. We spend a lot of time writing code and then debugging that code. And it's not uncommon to find ourselves writing the same code over and over again, which is tedious, and worse than that, it's error prone. The less code that you have to write and the cleaner that code is, the faster you can finish your game. And extension methods can help you do just that. Write less code and cleaner code with fewer bugs, which means you can finish your game faster. Extension methods allow us to directly operate on an instance rather than needing to pass that instance into a method. And maybe even better than that, it allows us to do this with types that we don't have access to, such as the built-in types in Unity. Or maybe you have an asset from the asset store and there's types in there that you also don't have access to. Now, as a side note, in my opinion, learning game development is all about adding tools to your toolbox, and extension methods should be one of those tools. So let's take a look at how they work and why they are better than some other solutions. In a past project, I needed to arrange game objects on a grid. The grid lattice was 1 by 1 and set on integer values. The problem, or more realistically, the pain point, comes from positions in Unity being a vector 3, which is made up of 3 floats, not 3 integers. Now, there is the type vector3int, and I did use that structure to store the position of the objects. But casting from vector3 to vector3int isn't built into Unity. And sure, you could create a conversion operator, but that's the topic of another video. So when I was faced with this inconvenience, my first thought, of course, was to write a function that takes in the vector3, rounds each component, and returns a vector3int. And this works perfectly fine. But this method is inside a particular class, which means if I need to do the conversion elsewhere, I need to copy that function into a second class. This means I'm duplicating code, which is generally not a good practice. So okay, fine. The next step is to move that function into a static helper class. I do this type of thing all the time. It's really useful. The result is more code than we need. It's not a lot more, but it's still more than we need. If this was my own custom class or struct, I'd just add a public function that could handle the conversion. But I don't have access to the vector3 struct. Yet I have some needed functionality that will be used repeatedly, and I want to type as little as possible while maintaining the readability of my code. In this situation, this is exactly where extension functions shine. So to turn our static function into an extension function, all we need to do is add the keyword this to the first input parameter of the static function. And then we can call the extension method as if it was part of the struct. Pretty easy and pretty handy. Now, before we look at some other examples, it's important to note that with extension functions, the type that you're extending needs to be the first input parameter in the function. Also, our static extension method needs to be inside a static class. Miss one of these steps, and your extension function's not going to work correctly. So with that said, let's look at some more examples of what you could do with extension methods. These are, of course, highly dependent on your game and what you need to do, but maybe these will spark some ideas and creativity. So maybe you need to swap the y and z values of a vector3. I definitely have. That's no problem. Or maybe you need to set the alpha channel of a sprite in a sprite renderer. Yep, we can do that. What if you need to reset a transform locally, globally? It's a piece of cake. Extension methods also work for inheritance. For example, most Unity UGUI components inherit from unityengine.ui.graphic, which contains the color information. So once again, it would be easy to create an extension method to change the alpha for nearly every UGUI element. Now we're starting to talk about some real added functionality. And we can take a step further down the tunnel of abstraction because extension functions also work with generics. Now, if you're scared of generics or you have no idea what I'm talking about, you might check my earlier video on the topic. But either way, let's imagine you have a list and you want every other element in that list or some other sorting. And of course, there's other ways to do this, but one way to do that filtering would be with a generic extension method like this one. And that's it. Extension methods are pretty simple and pretty easy to use. And I'd argue that they provide another tool to write simpler, cleaner, and more readable code. So I hope that was interesting and better yet useful for you and your project. If it was, check out these other videos. And until next time, happy game designing.